Hey makers, welcome back to HUB360 Embedded Sphere, where we build smart practical embedded systems with components you can get right here in Nigeria. Today's project is a multi-sensor environmental monitor that does three things. Number one, measures air temperature, measures altitude, detects harmful gas levels, and sounds an alarm when it crosses a safe threshold. All values are displayed on the LCD screen, and a buzzer alerts you when gas levels rise. Great for indoor air quality monitoring and early fire or gas leak detection. And remember, all the components used in this project are available at hub360.com.ng. Here's what the system does. It uses an MQ2 gas sensor to detect flammable gases or smoke. A BMP180 sensor gives us both temperature and altitude data. A 16x2 12C LCD display displays the live readings, and if the gas level exceeds a preset limit of 40 ppm, a buzzer is activated as an alert. Now, the components used. One, we use one Arduino Uno board, an MQ2 gas sensor, a BMP180 pressure and temperature sensor, and LCD, 16x2 LCD, an active buzzer, and a power supply, in this case our battery. This is a 7.2 voltage source. And we also have the jumper wires and the breadboard. Okay, connections. Let's break down the connections. MQ2 gas sensor. We connect the VCC to the 5 voltage on the Arduino board. Okay, there you have it. And then we connect the ground, the GND on the MQ2 sensor to the GND on the Arduino board. Okay, next, we connect the analog pin, which is labeled A0 on the MQ2 sensor, to the analog pin on the Arduino. Alright, moving on to the next item, the next material, BMP180 sensor. We are connecting the VCC on the BMP180 sensor, this is it, to the 3.3 voltage on the Arduino. And the GND on the BMP180 sensor to the GND on the Arduino. We connect the A4 pin to the A4 pin on the Arduino. The SDA on the BMP sensor, connect it to the A4 pin on the Arduino. And then connect the SCL of the Arduino to the A5 pin on the BMP sensor. We have our 12C LCD display, and then we are connecting the VCC on it to the 5 voltage on the Arduino. Alright, now we are connecting the I2C LCD display. First, we start by connecting the VCC on the I2C LCD display to the Arduino 5 voltage. So now we are connecting the GND on the I2C LCD to the ground, the GND on the Arduino. Then we are connecting the SDA on the I2C LCD to the A4 pin on the Arduino Uno. We are connecting the SCL pin on the I2C LCD display to the A5 pin on the Arduino Uno. Finally, the buzzer. We connect the positive end of the buzzer to the D8 pin on the Arduino. We are connecting the negative pin on the buzzer to the GND on the Arduino. Okay, quickly, code walkthrough. Let's walk through the Arduino code section by section. First, library inclusion. We included a library. So we include libraries for the I2C communication, which is the first one you're seeing here, and then the BMP180 sensor and the LCD display, and then pin and object setup. Pin and object setup, we define MQ pin as the analog input from the gas sensor, and buzzer pin as the digital pin for the buzzer. And then we set our gas threshold as the ppm level where the buzzer should be triggered, which in this case is 40 ppm. Then we create BMP and LCD objects to interact with both sensors. This is here. So the setup function, go to the voice setup. Start the serial monitor. Start the serial monitor, initialize and turn on the LCD, and set the buzzer pin to output and turn it off initially. Then try to connect with the BMP180 sensor. If not found, it halts the program with an error on the LCD serial, as you can see here. Then we go to the loop function. In the loop function, we read the gas sensor's analog value and map it to a ppm range of 0 to 300. And then we read current temperature and altitude using the BMP180 sensor. Then if gas level crosses, this if statement, if gas level crosses the defined threshold, the buzzer activates, otherwise it stays silent. We print real-time data to the serial monitor for debugging or logging on the serial print here. Then in the display aspect or section, we display temperature and altitude on the top row. The top row and gas level in ppm on the bottom row of the LCD. Just as stated here. We wait 2 seconds before the next reading cycle. And that's with the code. Now upload and final test. Try bringing a lighter or burning match near the MQ2 sensor. Alright, the gas value increases, and when it crosses 40, the buzzer alerts you. Okay, now you can hear the buzzer. It means your real-time environment monitor is now fully functional. And that wraps our build. You've created a gas, temperature, and altitude monitoring system and an audible alert practical for home safety, school bus, and IoT projects. Like this video if you found it helpful. Subscribe for more DIY electronics tutorials. Get your components fast and reliably at hub360.com.ng. Until next time, keep building, keep learning. This is HUB360 Embedded Sphere, helping you bring your ideas to life.